Example number 4, determine a square root of a non-perfect square. So we have another definition here. The definition for a non-perfect square, and that is a number that cannot be written as the product of two equal factors. So for example, we know that 16 is a perfect square because 4 times 4 is 16. That's two factors that are the same being multiplied together. But 17 is not a perfect square because you can't multiply a number by itself to get there. Back to the concept of benchmarks, 4 times 4 is 16. The next possible factor above 4 is a 5. 5 times 5 is 25. So that's a big leap going from 16 to 25. It's not 17. So 17 is not a perfect square. So it's a non-perfect square. But we can still estimate. And again, we're going to use benchmarks. So for example A, we're estimating the square root of 0.73. So we need to think about the square roots, the perfect squares that are close to, well, in this case we're going to use 73. Because this is the same as 73 over 100. That's what we're calculating. 100, no problem, that's a perfect square. It's the 73 that's causing us some trouble. So, go back to that list again. The numbers that are closest to 73, well, we'll start with 64. That is close. That's 8 times 8. That's the one right below 73. The one above it on that list was 81. So that's 9 times 9. Let's take a look here. So 73, if you look on the right hand side here, fits in right here. So we're going to use the one right above it and the one right below it as benchmarks to estimate the square root. So that's what we've done here, is we've gone with 64 and 81, or 8 squared and 9 squared. So if we know that 8 squared is 64 and 9 squared is 81, we know that 73, the square root is going to be somewhere between 8 and 9. So, square root of 0.73 is about halfway between the square root of 0.64 and 0.81. So we've got a number line here. Square root of 0.64 is going to be 0.8. Square root of 0.81 is going to be 0.9. So the square root of 0.73 is going to be right pretty much in the middle. This is a difference of 9, that's a difference of 8. So it's going to be a little bit bigger than 0.85 probably. But 0.85 is a very reasonable estimate. So it's going to be halfway between 0.8 and 0.9, which is about 0.85. This little squiggly equal sign means that it's approximately equal to. That's what that means. The square root of 0.73 is approximately equal to 0.85. Now we can calculate it. If we do that on your calculator, 0.73, then hit the square root button. It's actually 0.854403, and it keeps going. So we're going to round it to the nearest thousandth. So tenths, hundredths, thousandths. So that's 3 decimal places. So it's going to actually be 0.854. And so as is shown here, it's a fairly long number. We're going to round it to the thousandths, 10, 100,000. The next digit is a 4, so we don't have to raise this 4. It's going to stay a 4. Now, because we've rounded, it's not going to be precise. 0.854 times itself is going to give you 0.729316. 0.729316. So it does end, it doesn't fill your whole calculator screen, but that's not exactly 0.73, and that's the problem with rounding, is you lose precision. It's very, very close, but it's not perfect. All right, last thing in the chapter, go ahead and do your show you know.